Welcome back to the channel where we turn boring data into brilliant AI magic. Today we're diving into a real-world problem that so many businesses and developers face: information overload. Imagine you're working in a company with thousands of products, documents, or computer support tickets. You've got the data but no way to actually get answers from it without digging forever. Search boxes? No. They only work if you know exactly what to type. And let's be honest, who knows exactly the right keywords? So here's the problem. How do we make our data useful, like instantly, naturally, and conversationally? Now imagine this. You tell me about city bikes. Your AI, through your product database, not just for exact words, searches, but for similarly meaningful content. Then it actually explains the result like a real assistant summarizing its three questions, even chatting with you. Boom. That's what we're solving today. So we built an AI Copilot using FAISS for lightning fast semantic search, sentence transformers from Hugging Face, and then AI language generation model like ChatGPT to turn research results into natural, friendly responses. And we're doing it all in Google Colab with open source models from Hugging Face so anyone can follow along without needing a massive budget or enterprise tools. So if you've ever wanted to build your own AI assistant, a chatbot, or smart inventory search system that talks back like ChatGPT, this series is for you. The solution can also optionally support voice interaction enabled hands-free communication through text to text and text to speech modules. If you want to see this happen in the next video, please subscribe and let me know in the comments below. Thank you. So in an era where AI assistants are becoming integral to productivity, most tutorials tie you down into cloud platforms like Azure or AWS. But what if you could build your own AI Copilot, fully open source, scalable, and intelligent using just Hugging Face and Google Colab? This project demonstrates how to craft a powerful voice-ready AI Copilot that can answer questions, search documents intelligently, and respond conversationally without relying on Azure OpenAI or Cosmos DB. So instead, we will be using cutting-edge Hugging Face models, the FAISS for vector search, and optional open source speech tools for a hands-free experience. Think of it as ChatGPT meets your data under your full control. So we'll break this down into a few functional needs. So first will be the embedding vector generator, followed by vector search with FAISS. Then comes the LLM response generator, followed by voice IO, which will be optional. Okay, so let me first make you understand why we'll be using this. Why are we breaking it down into these few functional building blocks? So first, the embedding generator. What it does is first we'll be using Hugging Face's sentence transformers to convert text data into high-dimensional vectors. Then these embeddings capture meaning, not just keywords. Okay, so instead of doing naive keyword matching, we use this FAISS. It is a Facebook's vector similarity library to find conceptually similar documents based on user queries. This mimics how humans retrieve memories based on meanings. Then we'll be using a Hugging Face conversational model like we'll be using Mistral 7B or Phi 2 to generate intelligent answers and uses query forming a lightweight but powerful RAG loop. Then, if we want hands-free interaction, we bring in Whisper for speech to text and for text to speech, whatever, allowing you to talk to your Copilot and get verbal replies. Okay, so why this approach works and why we did it this way. So, first, no Azure subscription, no problem. Everything here runs on Google Colab or your local machine, giving you ownership over your models and data. Then, Hugging Face models are transparent, customizable, and don't lock you in a specific ecosystem. And if you want to swap in another LLM or voice model, each layer is decoupled, making it very easy to upgrade, experiment, or even deploy in production. This isn't a toy chatbot, mind you. With vector search and generation, you get answers that are relevant, explainable, and adaptable to any use case. For example, inventory will be working. You'll first connect, then first we'll set up the Google Colab environment. We'll start by installing the libraries that we need, that is this will take time. Okay, so till then, we'll load the dataset or a sample knowledge base. So let's use a simple product or FAQ dataset, that is data followed by category will be by name. Name will be category will be bike and name will be mm, Roadster 500. Info would be a lightweight bike for city travel. Next, we'll be generating embeddings with Hugging Face from sentence transformers. We'll import sentence transformer, and the model that we'll be using is sentence transformers or mini LM L2. Yeah, Google Gemini is helping us after all. Then for item and data text, we'll keep it as category, then followed by the item, then the category again, followed by the name, and the, the information item, we'll be embedding it. Embed underscore model dot encode text dot to list. Till this code runs, we'll write the following code. So the next step will be to set up vector search with FAISS. So we first import FAISS, import numpy as np. Then we'll okay, great. So the model is running great. It's working very well. Oh, embed model is not defined. Oh, so we named it model here. No problem. Great. We solved it. Next, get the length of the embeddings. We'll assign it to dimension variable data. Okay, index is equal to FIASS dot I and no, index flat dimension 2, right. Then the okay, so this needs to be assigned a variable vector and the array list item for items in data. Great. Let's define it underneath this. Great. Oh, import FAISS. FAISS. See, that's a common mistake. Next, we'll search similar documents using vector search, okay? So first, we'll define search. We'll pass parameters as query, and we'll assign k as 2, followed by query embedding will be, no, we'll embed the model here. Then we'll encode query. Distances and indices will be the index dot search np dot array array query embeddings. Great. Then we'll return data I and indices 0. Great. Now that we've defined the search function, great. So now that we've defined the search function to find a similar documents using vector search, let's put it to test. Let us assign a variable result to search. Let's search a city bike. Okay, so based on the information here, we'll search city bike for our end results, print R. Mm, ah, this error again. Okay, so to solve the query embedding error, I think we should again call the query embedding. We should, so we'll search this. We'll search a city bike and run this. So it is located, so hence it's showing true. And then third, okay. So after this, let's put it in a for loop for item in query embedding. We'll print the item name followed by the type. So be embedding in an array format. Then we'll change the data type. Oh, array, right. So when it is found, the Roadster 500 and the Mountain Pro bikes are converted into float. Yes. So we're on the right path. We searched for a city bike. City bike would be a durable mountain bike and a lightweight bike for city travel. So it's correct. Now, this is work end-to-end in Colab. Let me know if you want to add on response generation with LLM next. Okay, so now that this is done, now that we can search and the name of the bike is being retrieved correctly, uh, let's now layer generation, response generation, using Hugging Face only. The Hugging Face LLM, that is like a distilled version of ChatGPT or Llama, on top of the FAISS based vector search that we had initiated about. So this gives our AI Copilot the ability not only to retrieve the relevant content like we did here, also to summarize and, you know, answer questions conversationally, like ChatGPT or like open source. It's like it'll be like fully customizable. We'll begin by pip installing transformers. Till then, we'll write the code for importing the LLM and tokenizer from a Hugging Face from transformers. You import the pipeline. Then next, we'll be loading the model generator. Will be the pipeline text generation. No, we can swap this with a larger one later, but for now we'll be using the model Distill GPT-2. ChatGPT, not GPT, Distill GPT. Okay, Now we'll be defining a function to generate a response. We'll pass in the top search result and let the model respond as if it's answering a question about it. So let's begin with defining the function of generating responses. Generate response query. Okay, so here we'll have to um, put a parameter known as search results. Okay, so the well, first we'll give the context will be first we'll construct a basic prompt using like the top result. So we'll assign a variable context to searching the results. We'll give it a prompt. Query, then the context, query and context. Oh my god, okay. Oh my god, okay. Query and context. We'll assign this context variable. Next, we'll be generating responses. Next, we'll write the code to generate response. The output will be a generator. Prompt will be the input. The max length, we'll keep it as 100 for now. Okay, length. Followed by we'll do sample true, and instead of the top gate that popped up, we'll use temperature. Temperature, we'll keep it as 0.7. Great. Now let's return this output. Generate text. Great. Now we'll be combining the search and generation part. So we'll assign a variable query. We'll give it a query as, let's keep it interactive. Tell me about city bikes. Okay. We'll use the search results variable, searching the query. Okay, great. Followed by we'll be printing the top search result. Search for results that we defined above, followed by a response. Okay, great. We'll generate response parameters query, then the search results, and we'll print the response. We'll kind of like, let's keep it, Copilot says. Okay, so this was supposed to be do sample, and then when we run this, So the top search result for the category bike and the name roadster, and the information is given. The embedding was negative 0.01. The context was to give a lightweight bike for city travel. So the answer that it generated was I love the bike, but I also love the bike, which I use daily in my daily life. I have to be on a bike to be an experienced biker. I do not know if a bike is a bike that I can ride without any help. So these responses are based on the model that we use, this tool, GPT-2. Different models will behave differently. So we can swap it in a more powerful LLM, like using different models for GPU or using Hugging Face interface. We can fine-tune a small LLM on our own product descriptions or internal documents. We can also add multiple results into the context with a better RAG-like experience. This is not the last step in this project. We can also add a speech interface. We can deploy it as a RESTful API using Fast API. We can connect to a real MongoDB, but of course that will be this. But of course, I feel that'll defeat the purpose of the project since we're using a substitute for AWS and Microsoft's. Hence, we're using Hugging Face. You can also optionally support voice interaction. If you want, let me know in the next video. We can enable hands-free communication through speech-to-text and text-to-speech modules. This will make the system ideal for use cases such as intelligent chatbots, inventory assistants, educational tutors, and enterprise knowledge co-pilots. Thank you. Thanks for watching. Please subscribe.